Ya, Assalamualaikum warahmatullahi taala wabarakatuh. Today we will present our assignment, which is project bridge application and architecture engineering. We are from group 1 and 10. So, firstly, I will introduce our group members. Firstly, Muhammad Nakiuddin bin Senin, Muhammad Abi Ali bin Muhammad Ali, Amir Aziz bin Wahid Ghaffar, Muhammad Amirul bin Muhammad Arifin, and Fadi Farhan bin Murni. So we are from 3 BMMV, section 1 stroke 1, and our lecturer name is Dr. Noh Hazwani binti Mukhtar.
Okay, for the background, a bridge is a construction meant for carrying the road traffic or other moving loads in order to pass through an obstacle or other construction. The required passage may be for pedestrian, a road, a railway and canal, and a pipeline. Obstacle can be rivers, valleys, sea, channel, and other construction such as bridge, themselves, building, railways, or roads. Okay. For the second, bridge is a structure that provides passage over obstacles such as valley, rough terrain, or bodies of water by spanning those obstacles with natural or man-made materials. They first began be used in a ancient time when first modern civilization started rising in the Mesopotamia. From that point on, knowledge, engineering, and manufacture of new bridge building materials spread beyond their borders, enabling slow but steady adoption of bridge all across the world. Next.
Okay, for the problem statement, a bridge is a structure that spans a valley body of water, roadway, headroll, tracks, or any other obstruction to continuous travel. Bridges also are designed to withstand dead loads and live loads. A dead load is a load that does not change, such as weight of the structure itself. This load accounts for a significant and considerable percentage of the stress in the load carrying member. Live load change. The change can be due increase or decrease traffic and pedestrian loading. Next. Next. Okay, for the objective, we have three objectives. First, develop an understanding of the requirements of the material used in bridge constructions. Second, understand how each bridge structure works to carry the loads placed on the bridge. And lastly, third one is analysis important aspect of construction such as strength and placement of materials. Next.
Okay, for the literature review, we have to start. Material used in bridge construction. In according with Composite Engines 2006 journal, making carbon fiber composite material into strands and rows and then mixing them with steel bars for bridge construction is the most common application of carbon fiber composite materials. Carbon fiber composite material were made into strands and first used in the construction of high-speed post-tension pre-stressed concrete bridge in Germany in the early 1990 years, where a wedge-shaped bridge anchoring system was used. Next, how design each bridge work. The bridge model lower court had four bearing pads to ensure proper thrust behavior based on Basical's 2017 journey. Pin and roller support were placed near the first and 11th floor beams respectively under the bearing pads. To monitor the deflection of the bottom part, linear variable displacement transducer were used as displacement gauge or DG. The loading operation was complete in 4 steps, starting with the placement of the bridge on the FB from pin support to roller support. Next, arrangement of displacement. Okay, this arrangement of the displacement gauge, figure A and figure C, load distribution on a wooden bridge deck. Next. strength and placement of material. The experimental investigation of a pedestrian bridge model composed of GFRP profile is present in this work, based on Journal Basis Cars 2017. Post-static loading ways were used to evaluate the bridge prototype. The maximum load is 13.3 kilonewton. A numerical model was created using the CAD software SolidWorks to compare experimental and theoretical results. According to the finding, the manufacturer of GFRP profile announced a Gaussian modulus of elasticity resulting in increased structural stiffness. When the nominal value of Young modulus is taken into account, deflection inaccuracy range from 29.3 to 43.9%. Consideration the experimental obtained helps average value, the margin of error at maximal loading is just 0.3%. More research is needed to analyze the dynamic behavior of GFRP composite bridge as well as their long-term consequences.
Okay, for the result, our simulation is use the material names balsa wood. We got the result for the yield strength of this simulation is 2 exponent 7 Newton per meter square. Elastic modulus 3 exponent 9 Newton per meter square. Position ratio 0.29. Mass density for about 160 kilogram per meter cube. Shear modulus 3 exponent 8 Newton per meter square. Okay, for the upper bound axial and bending, for the stress analysis, the maximum stress for this structure is for about 21 mega Newton per meter. Next. For the displacement analysis, the maximum displacement for this structure for about 2.53 millimeter, and the safety factor for this simulation minimum for about 0.94 and maximum is 3.0.
Okay, for the discussion, the material that we use in this bridge is wood, which is balsa, and other than that, we decide to apply 5.832 pound force during the simulation analysis study. For example, on the figure that we at the other slide below show, we can see the value of maximum resultant displacement that occur in this bridge is between 0.00 exponent 0 millimeter and 2.530 exponent 0 millimeter. And next, for the conclusion, this paper presents the experimental investigation of bridge model made of balsa material. Bridge prototype was tested under 4 static loading stage. The load value has been selected as 5.832 pound force in accordance with the bridge design regulation. Deflection of the bridge were monitored at every loading stage in 10 bridge nodes. In order to compare experimental and theoretical results, the numerical model was developed employing CAD software SolidWorks. Analysis has shown that the manufacturer of GFRP profile declared precaution conservative value of modulus of elasticity, which the result is higher structural stiffness. In case the nominal value of Young modulus is inconsiderate, which is 2 exponent 7 Newton meter square, the error of deflection reached 29, 3 until 43.9%. At the maximum loading, 21 mega Newton meter square, Margin of error account for only 23%. Considering experimental attempt, which is average value. Investigation revealed that GFRP profiles are suitable for real bridge superstructure. Future research is needed for assessment of dynamic behavior as well as long-term effect of GFRP composite bridge. Yeah, this all from us. Thank you.